All right, welcome. Today we're going to jump right back to basics and take a look at the classic components of a strong network defense, how they're designed, and more importantly, how they all work together.
Okay, let's dive right in. A secure network isn't just one single thing. It's really a complex system of interconnected zones and policies. So you gotta think of it less like a simple brick wall and more like a whole fortified border, complete with checkpoints, secure tunnels, and a very carefully controlled buffer zone.
So how do we actually build a border like that? In this explainer, we're going to break down the 3 core components that security analysts use every day to construct and defend these perimeters. My goal is to give you a really clear picture of how each piece functions.
We'll kick things off with the wall itself, the firewalls. Then we'll look at the secure gates that let trusted traffic get through. That's our VPNs. And finally, we'll see how it's all assembled into a strong, defensible architecture using something called the DMZ.
First up, firewalls. Now, it's really crucial to understand that firewall isn't just a single concept. This technology has evolved a ton over the years, getting way smarter and more powerful to deal with increasingly sophisticated threats. So the granddaddy of them all is the packet filtering, or stateless firewall. Think of this like a border guard who only looks at the source and destination addresses on a passport. The IP addresses and port numbers. It doesn't remember anything about traffic that came before it. Every single packet is a brand new decision based on a simple list of rules. And because of that, this type of firewall has a pretty limited scope. It only looks at traffic at the network and transport layers. It has absolutely no visibility into the application layer, where the actual data lives. This makes it totally blind to more advanced attacks that might be hidden inside that traffic.
After that, we got a major upgrade, the stateful firewall. This is a much smarter guard. It doesn't just check your passport, it actually remembers that you're part of an approved ongoing conversation. It keeps a state table to track active connections so it can automatically allow return traffic without needing a whole new rule. This was a total game changer for both security and efficiency.
And that brings us to the latest evolution, the next generation firewall, or NGFW. Now think of this as a guard who can actually inspect the contents of your luggage, the application data itself. It performs deep packet inspection, meaning it understands applications. It knows the difference between web browsing and file sharing, even if they're using the same port. Plus, it bakes intrusion prevention systems right into the device.
So when you lay it all out like this, you can really see the progression. We've gone from simple, stateless rules based on addresses to stateful session tracking, and now all the way to full application layer awareness and control with NGFWs. Each step just gives you a deeper, more context-aware level of security.
Okay, so we've built our wall, but now we need a safe way for trusted users and sites to get through it, right? And that, of course, is where virtual private networks come in. They are just absolutely essential for things like remote access and connecting offices securely.
So what's a VPN really doing? Well, at its core, it's creating a secure, encrypted channel to protect your data as it travels across untrusted networks, like the public internet. It basically wraps all your traffic in this protective, private bubble, making it unreadable to anyone trying to snoop.
But how does it do that? Well, if we're talking about the IPsec protocol, which is super common for site-to-site VPNs, the key difference really lies in 2 modes, tunnel mode and transport mode. They get to a similar goal, but they do it in slightly different ways.
Okay, let's break this down, because this is a key difference. Look at tunnel mode. See how it encrypts the entire original packet, header and all, and then wraps it in a completely new one? This is perfect for gateway-to-gateway connections because it completely hides the internal source and destination. Transport mode, on the other hand, just encrypts the data payload, leaving the original IP header exposed. It's more efficient for direct host-to-host chats where hiding the endpoints isn't the priority. All right, so we've got our smart firewall, and we have our secure VPN tunnels. Now let's put it all together. How do security architects actually use these pieces to build a solid, classic perimeter architecture? Well, they use something called a DMZ, or a demilitarized zone. And honestly, it's a brilliant and timeless solution to a really common problem. How do you offer public services, like a web server or an email server, without exposing your private, trusted internal network to direct attacks from the internet? Simple. You create a buffer zone.
And you can see in this classic setup, the firewall is basically the traffic cop for the whole operation. It enforces strict rules between 3 totally distinct zones: the untrusted public internet, the semi-trusted DMZ where your public servers are, and the fully trusted private internal network. Traffic from the internet is allowed to hit the DMZ, but it's explicitly blocked from ever reaching the private network.
Now, when you're building this, you've got a couple of options. You could go with a simpler single firewall design that just uses different interfaces on one device, or for a more robust, layered defense, you can use a dual firewall setup. This actually separates the external and internal security policies on two different devices, which means an attacker would have to compromise two separate firewalls to get to your internal network.
So let's just recap the big takeaways here. These three components really are the bedrock of traditional perimeter security. We've seen how firewalls have evolved into intelligent, application-aware NGFWs. We know VPNs use protocols like IPsec to create those secure tunnels, and we know the DMZ provides that critical architectural buffer to protect our most important internal assets.
But here's the thing. As technology shifts, with our users, our data, and our apps now scattered all over the cloud, the very idea of a single static perimeter is kind of dissolving. It's pushing the whole industry towards new models like zero trust. And that leaves us with a really critical question to think about for the future. If the castle walls are gone, how do we protect the kingdom?